Good morning all of you. Today I am giving lecture third, idea of band structure materials. So in this way I discuss about materials and with their band gaps. So starting with the energy band gaps in solids. In solid materials, electrical energy level form bands of allowed energy separated by the forbidden bands. Valence band, conduction band and gaps. So valence bands is the outermost band filled with the electrons, and conduction band which is the next highest band to valence band which are empty. Gap is to show the energy difference between the valence band and the conduction bands. Electron is in a completely filled band cannot move since all the states occupy. Only way to move a band would be to jump into the next higher band needs energy. Electron in a partially filled band can move since there are free states into classification of solid into three types according to their band structure: insulator, semiconductor and conductor. As the conductor, we know the conductor their band gap is very high, so the no charge carrier is moved from because the charge carrier is present in the valence band is more and there is no charge carrier present in the valence bands. Similarly, free electrons are available in the conduction bands and charge carrier is moved from valence band to conduction band to valence band, which is known as holes. So energy gap is 1 electron volts. Then we see insulator, so there is a band gap is very high, so no charge carrier is moved from conduction band to valence bands. So in this way, semiconductor, insulator and metal will be. Conduction band conductor material capable of carrying electric currents. Materials which has a mobile charge carriers. A metal which is a very good carrier of electricity is called conductor. In a conductor, the valence and conduction band overlap, so practically the energy gap is zero. Thus electrons need very little energy to stay in the conduction band and conduct electricity. Valence band only partially filled or the next allowed empty band overlap with it. Conductor, if the electron to become free to conduct means it's been promoted into the empty available energy states. Similarly, conductor for metal, these empty states are adjacent to fill the states. Generally, energy supplied by the electric field is enough to stimulate electron into an empty state. Insulator, material with no or very few free charge carriers. Gap, forbidden region between highest filled band and lowest empty or partial filled band is very wide, about 3 to 6 electron volt. In an insulator, the valence band is filled with the electrons, so electron cannot move with the valence band. In order to produce conduction band of electricity, the electrons from the valence band must go into the conduction band. Thus, the energy of more than the energy gap must be supplied to the electron in the valence band in order to transfer them into the conduction bands. Insulator, practically it is impossible for an electron to jump from the valence band to conduction band, hence the material cannot conduct electricity and it's called insulator. Semiconductor is a material in which electrical properties lie between those insulator and conductor. In terms of energy band, a semiconductor can be defined as the those materials which have almost empty conduction band and almost full valence band. The energy gap is very small and very little energy is needed to transfer electrons from the valence band into the conduction bands. Even the thermal energy at room temperature is enough. By raising temperature, more and more electrons will be transferred to the conduction band. Effect of crystal size on density of states. In a solid state, physics and condensed matter physics for the density of states of a system describe the number of states and that are to be occupied by the system at each level of energy. So the probability density function, and it is generally average over the space and the time domains of the various states occupied by the system. At the density of the states, so electrons are band edge between the valence band and conduction band in the semiconductor for an electron conduction band, and an increase of the electron energy makes more state available for the occupations. The band gap of a material, this condition also means that an electron at the conduction band edge must lose at least the band gap energy of the material in order to transition to another state. Electron structure, when the atoms forms a lattice, the discrete energy of the atoms and are smoked into the energy band, the term density of a state refer to number of energy level in a given interval. When metal particles of bulk size is reduced to few hundred atoms of the density of a state in the conduction band, the top band containing electron changes automatically. The continuous density of state in the band is replaced by state of discrete energy level. So that is all about this lecture third. Thank you all.